If you torture the data long enough, it will confess to anything. Quoted by Ronald Coase. Hello all, my name is Pawan Kakade, and today I am going to give a lecture about descriptive analytics. As we have seen earlier, I have told you that there are three types of analytics: descriptive, predictive, and prescriptive. Among all of those three, descriptive analytics is the one in which what we do is we study on the previous data. We do some studies, we do some statistical studies on the historical data. So let's begin today's lecture. This lecture is going to be very informative, and I will use all of the mathematical concepts which are related to the descriptive analytics. This is not a theory lecture, this is all going to be a practical one. After the completion of this video, I will upload another video in the same series where I will solve various different problems which is related to descriptive analytics. Let's begin. So, what is mean? Mean is nothing but an average value. So here is the formula of sample mean, which says x bar, which is equals to summation of xi in denominator n. N is nothing but the number of sample or sample size. Let's understand this with the help of a small example. We have series 1, 2, 3, 4, 5, and let's take a random variable as x, and we have numbers like 10, 12, 7, 4, 6. So how to calculate mean with the help of this example? Mean will be calculated as in x bar, so the summation of this, so the total of this x is going to be indicated as summation xi, which is going to be 39. Summation of this x, the values of this individual x, is 39, and we have the sample size, the number of samples n, which is equals to 5. So the mean will be calculated as x bar summation of xi, which is going to be 39 divided by 5. So the mean comes around 7.8. Alright, this is how we calculate mean. X bar 7.8. Very simple. We'll do some problems in the next video. So this is just a concept which I am explaining right now. Let's move forward. Median. What is median? As in the word says, median is a DI which is in the middle. So the middle value of data arranged in ascending order is defined as median. Let's understand this with an example. We have one example where we have a series of numbers like 7, 5, 3, 1, 4, 6, 2. So to calculate median, we have to remember two steps. Step 1, arrange the series in ascending order. So here we go, 1, 2, 3, 4, 5, 6, 7. Step 2 is to select the middle value. So as our series is consists of odd numbers, and we know the middle will be going to be 4. So 4 is our median. Okay. But what if the series is even, like 6, 5, 1, 2, 4 and 3. The same thing, step 1, arrange in ascending order 1, 2, 3, 4, 5 and 6. Now in odd numbers we know the middle will be 2 values, so in this case we have 3 and 4, right, and the series is even. So in the even series we are going to select this 3 and add this 4 to it, and we'll divide it by 2 as we have the even series. So this is going to be 7 divided by 2, which is going to be 3.5. So in the case of even series, our median will be 3.5. Okay. Mode, very interesting. Mode, as it is defined as the most frequently occurring value in a data set. So we have data sets like this: 1, 7, 9, 4, 3, 4, 5, 6, 8, 4, 7, 2. So this is our data, and in this data we can see that 4 is repeating thrice. So our mode in this case is going to be 4. Here in this data 7 also repeating, but 4 is repeating thrice compared to 7, which is only repeating twice. So 4 is going to be our mode. That's it. Very simple and very easy. Now frequency. Let's understand frequency. So what do you mean by frequency? Frequency is nothing but repetition. For how many times a value is being repeated. For example, we have apple and banana. So apple is getting sold for 3 times in a day, but banana is getting sold for 10 times in a day because banana is cheaper than apple. We can derive that. So frequency is nothing but repetition. How do we calculate frequency? Let's understand this with the help of an example. We have so this is just a random example, A, B, C, D. Okay, and we have their frequencies given as 10, 15. So the total will be 70. This is our total frequency, in short form TF. This is our frequencies, individual frequencies, means something is getting repeated. Now let's understand what is relative frequency. So relative frequency is going to be how much it is relative to the total frequency. For example, the question comes in mind is what is the relative frequency of A will be 10 upon 70. So this is going to be our relative frequency, 0.142. Similarly, 15 divided by 70. So the total relative frequency is going to be always and always 1.00. Note and remember this fact. Whenever someone will ask what is the value of relative frequency, the ultimate value, or we can say the total value, so you must answer it is 1, and you have to remember this. This is always and always 1. When you will add individual relative frequencies of every individual elements in this data, you will see the summation comes up as 1. That's it. Okay, So now let's understand what is variance. Alright, variance is the measure of variability that utilizes all data. Means how much the data, how to measure the variability in the data, how the data is varying from each other is called as variance. So simply the formula is given above. It is mentioned as s square is equals to summation of xi minus x bar whole square upon n minus 1. So let me explain you this with the help of example. What xi and x bar means. X bar means it is a mean. Xi means individual data or element. Then n means sample size. That's it. So let me give you an example with the help of a table, a data table. We have 1 2 3 4 serial number, and we have elements like 3 5 4 and 2. So these are the elements which is denoted as xi. Now we have to calculate x bar. So x bar is going to be the total summation of this 14 and the mean will be 14 divided by number of samples, which is 4. So 14 divided by 4 is going to be 3.5. This is our mean. Now we have to calculate xi minus x bar. So how? So we know xi is 3 for element number 1 and x bar as 3.5. Similarly 5.5. We calculate each one of these, you will get minus 0.5. So after calculating we got these values, and what we're gonna do is we're gonna square these values, xi minus x bar whole square. So this will be as alright. After calculating we got the squares of every element. So what we're gonna do is we're gonna add all of these and we will get our final value as 5. Now let's calculate the variance. What variance? What is the formula of variance? S square is equals to summation of xi minus x bar whole square upon n minus 1. So we have our summation calculated as this 5.0, and we have number of samples as 4 minus 1 is going to be 5 upon 3 comes as 1.67. This is how we have calculated the variance. Standard deviation is nothing but, in simple words, it is the positive square root of variance. So in our earlier case what we did is our variance was around 1.67. So our standard deviation will going to be the square root of 1.67, which comes around 1.29. That's it. Very simple. Let's move on to the next one, which is coefficient of variation. So the definition says how large the standard deviation is relative to the mean. Let me explain you this concept with the help of an example. This is our scale, and in this scale 5 is our mean. Okay, so standard deviation is nothing but the this is going to be our standard deviation. I'll explain this concept in the next videos in very detail, but right now just try to understand this. This is going to be our standard deviation. Alright. Now how it is relative to the mean value, which is 5, is going to be. So in our previous example, our standard deviation was around 1.29 and the mean was around 3.5. So our coefficient of variation is going to be 1.29 divided by 3.5 into 100. So in this case, our coefficient of variation is 36.85%. Next, percentile is a detailed concept, and I will explain this with the help of a problem, mathematical problem. So right now, just understand the concept with the help of a definition. Value of a variable at which a specified percentage of observation are below that value. For example, I have a series like 100, 150, 75, 80 arranged in an ascending order. It is not arranged in an ascending order, but let's imagine that like 75, 80, 100 and 150. And I want to find in this whole series that what will be the value of my 80th percentile. So what I'll do is I'll take this L80 and this is going to be 80 upon 100 into, we know our sample as 4 plus 1. So this is how we will get our number in the 80th percentile. So 80 divided by 100. Okay, interquartile range, I'll also explain this in more detail in the next video. So let's understand what are these Q1, Q2, Q3 with the help of a box plot. So in box plot, the IQR is represented in the box where Q1 is this, Q2 is this, and Q3 is this. So square, let's take an example of a square. If we divide it into 4 parts, 1, 2, 3, 4 equally, and we get the first part, the value comes up as 0.25. If the area of this square is 1, and if we divide it into 4 parts, every individual part has a value as 0.25. Okay. Similarly, in the box plot, Q1 consists of 0.25, which is 25%. Okay. And from Q1 to Q2, this also consists of 25%, 0.25. That means the total overall Q2 is 50%. And from Q2 to Q3 is also same as 0.25, which is 25%. But from the starting to the till end, means 0 to Q3 accounts as 75%. I hope you understood this. So let me write this. Q1 is 25%, Q2 is 50, Q3 is 75. You only have to remember the values of this. These are known as quartiles in an interquartile range. The ranges from Q1, Q2 and Q3. That's it. Last but not the least is going to be Z-score. So Z-score, what the definition says is relative location of a value in the data set, how far a particular value is from the mean relative to the dataset's standard deviation. So just remember this formula for now, because the concept of z-score can be well understood with the help of normal probability distribution. This is a normal bell-shaped curve in which the the midpoint is determined as mean denoted by mu, and this whole height is nothing but our standard deviation, this thing, which is denoted by sigma. So I'll explain this concept in detail. In this line we have our z-scores, and every individual z-score contributes to probability. Alright, so this is negative side and this is positive side. With a value of positive 1 z-score gives you the probability of something which is available in the z-score chart. So I will explain this in the coming videos in very detail. Chapter number 6 is very much important. Chapter 6 to understand this concept, and this concept is really interesting. So stay till the end, and trust me, you're not going to regret it. You'll learn a lot from this chapter number 6. So that's it, guys. This is all for today's video. In the conclusion, what I want to say is that we have gone through various concepts, and I hope you have learned all of them. I hope you have understood about today's topic, and I hope this was interesting. Thank you, and bye bye. Good luck for your examination, and prepare well for this subject.